Okay, now let us continue. After we have our state table, the present state and next state derived from the state diagram. So you will list it all like this. And then you will need to table out what is the inputs of your your flip-flop. So, so this example is actually using a flip-flop type of JK type. So, before we can know what is the possible input to design for our 3-bit design gray code counter, you need to know the transition table for a JK flip-flop. So, this is actually the transition table of a JK flip-flop. Okay, what is actually inside the transition table? It is actually uh, showing that if your present state is starting with 0 and your next state is also 0, your input of J should be 0 and your input of K can be a don't care. Okay, so if on the present state of Q, your output is 0 and this is your present state. If your present state is 0 and then your next state change to 1, the input should be label J should be 1, K should be don't care. Okay, if the next condition is if your present state, the bit is 1 and then it transform into a 0 at the next state, so your input of J and K should be X and 1, don't care and 1. Okay, if your present state is 1 and then it will maintain at also 1 at the next state, so the input of J and K should be don't care and 0. So with this transition table, you need to write it down inside your state table. Okay, let us check line by line. Okay, for this, you need to check it using the column, okay, not by rows. So I want you to focus just on your Q2 and Q2 bar. Okay, so Q2 and Q2 bar. What is the input of J2 and K2? So starting from Q2 to Q0 to 0, 0 to 0, in the state table, it should be 0 to 0, it should be 0 and don't care. So 0 and don't care. So 0 to 0, 0 and don't care. 0 to 1. So let us check. If it's a 0 and it's changed to 1, it should be 1 and X. 1 and X. J is 1, K is X. Okay. Next line. So 0 and 0. It should be 0 and X. When it is a 1 and change to 0. When your present state is 1 and then it changed to 0. It should be don't care and 1. 1 and 0. 1 and 0. Don't care and 1. Okay. So next is when your present state is 1 and the next state is 1. 1 and 1. It should be don't care and 0. So J is don't care. K is 0. Okay. 1 and 0. Don't care and 1. 1 and 1. 1 and 1. So 1 and 1 should be 1 and 1. Don't care and 0. Okay. Finish for the input of J and K. So you need to check on the next bit, that is Q1 and Q1 bar. Okay, we will check on Q1 and Q1 bar. Okay, let us check together. If it start present state is 0, the next state is 0, it is 0, 0, it is 0 and X. 0 and 1, 0 and 1, 1 and x. 1 and 0. 1 and 0, sorry, 1 and 1. Okay? You need to be careful to check on the column and lines. 1 to 1, and the next line is also 1 to 1. 1 to 1 is x0. So x0, x0. Okay. Next, Q1 is 0. The next state is 0. 0 and x. Present state is 0. The next state is 0. 0, x. 1 and 1. 1 and 1 is x and 0. 1 and 0. 1 and 0 is x and 1. Okay. So, how about the next? The last column. Q naught to the next state of Q naught. So, 0 to 1. 0 to 1, it should be 0x. 1 to 1, x0. And then next is 0, 0, 0, 0, 0, 0, 0 and x. Is it correct? Oh yeah. 1 and 0. 1 and 0, x1. So this line, 0 to 0. 0 to 0 should be 0x. Okay, 1 into 0. The next state of 0. 1 to 0 is x1. 0 and the next state is 0. 0x. Lastly, 1 into 1. So 1 into 1, it is 0x. Sorry, x0. 0 to 0, 0x. 1 into 1 is x0. Okay, so you already have a full complete state table where you list down all your inputs, towards your flip-flop. So the next step is you need to draw a K-map for each input here. So you need to have a K-map for J2, K2, J1, K1, and J0, K0. So in other words, you need to have 6 K-map. Okay.